All right, so the most important thing you get from these functions is how to find the characteristics from each form. We're going to look at all three forms and make sure that we understand the process for finding all of our characteristics. Starting with vertex form, which is right here, f of x equals parentheses x plus 2 parentheses squared minus 1. So that's our vertex form. How do we know if it's opening up or down? Well, we always look at the a value to find that. If a is greater than 0, which means it's positive, then it's opening up. And if a is less than 0, meaning it's negative, then it's opening down. Now, where is our a value located? It is located right here in front. Remember, it is y equals a times x minus h squared plus k. In this case, a is equal to 1, which means it's positive, so we are opening up. Okay, the axis of symmetry comes directly from the x value of the vertex, which comes from our h. So if we're in vertex form and we want to find the axis of symmetry, it's just x equals h. So if we look here, our h is located right here. But now remember, it's a minus h, and it always comes out as the opposite. So for this problem, h is actually equal to negative 2. So that our axis of symmetry is x equals negative 2. Okay. Moving on to vertex. Now vertex, we already have the first part of it, h. The second part of our vertex comes from k, which is right here at the end. Now, since it's a plus k in our formula, then it stays as a negative 1. So our vertex we can pull directly from vertex form as negative 2, negative 1. So to find that, we always do h, comma, k. And in this problem, that would be negative 2, comma, negative 1. Just remember that your h is always the opposite of the sign you see. Well, your minimum or maximum value, that is going to come from your a. So first, look at a, right? So opening up has a minimum. And opening down has a maximum. So first look at a to determine that. And then you're going to look at the y value of the vertex. And that will always be your maximum or minimum value. So in this case, we are opening up. So that means that we have a minimum. And our minimum value is equal to negative 1, which is the y value of the vertex, which is k. Okay. Our x-intercepts, to find x-intercepts in vertex form, we've got to think about how do you find an x-intercept. And in order to find an x-intercept, you have to have a y value of 0. So I'm going to plug in 0 for y. This was probably the trickiest one out of vertex form. So here we go. I'm going to plug in 0 for y, which is also our f of x, and that's going to be equal to x plus 2 squared minus 1. I can get rid of the plus 1, or I'm sorry, the minus 1 by adding 1. And that's going to give us 1 equals x plus 2 squared. I can get rid of the square by taking the square root. So I'm just doing inverse operations. Square root of 1 is just 1. That's going to give me x plus 2. But now here's the tricky part. When you take a square root to solve, there has to be a plus or minus in front. That's because if I do 1 squared, I'd get 1, but I could also do negative 1 squared and get 1. So I have to account for both. So in this case, we are actually going to split apart our work. And we're going to do what if x plus 2 is equal to positive 1, and then what if x plus 2 is equal to negative 1. And this first one here would, if you subtract 2, you would get x equals negative 1. And the second one, if you subtract 2, you get x equals negative 3. So that gives us our x-intercepts, and our points then are negative 1, comma 0, and negative 3, comma 0. Okay, that one's the trickiest one out of here. That'll just take a little bit of practice. Your y-intercept is going to be similar to find your x-intercepts, but you plug in 0 for x, because if I'm on my y-axis, then that means my x had to have been 0. Okay, let's do that math. So that would have been f of 0 equals 0 plus 2 squared minus 1. And then I'm just going to simplify here. 0 plus 2 is 2. 2 squared is 4. 4 minus 1 is 3. So our y-intercept is 0, 3. Okay, so that is vertex form. Okay, when we're looking at standard form, we want to find opening up or down. We look at the same thing. You always look at A. But when we're looking in standard form, we've got to think of it as f of x equals a x squared plus bx plus c. So our a is that leading coefficient there, right in front. A is equal to 1 here. So we are opening up. Axis of symmetry has a special formula when you are in standard form. To find your axis of symmetry in standard form, you have to use the equation x equals negative b over 2a. Negative b over 2a. Negative b over 2a. Make sure you remember that, okay? So our b is the one that's in front of our x, and our c is the one at the end. So b in this case, let's see, a is equal to 1. B is equal to 4, C was equal to 3. We don't need C here, okay? I was just finding them all. So x equals negative B over 2 times my A, which is negative 4 over 2 times 1, which is 2, which is negative 2. So my final answer is x equals negative 2. Make sure you write x equals in your axis of symmetry. So standard form, you need that special equation. That's the benefit of this. If it was in vertex form, you wouldn't need a special equation. All right, so if I want to find my vertex in standard form, I have to first find the negative b over 2a, which we already did, and that's the x value of the vertex. To find the y value of the vertex, I plug it back into my function. Okay, and that's what this, let me show you what that would look like. So it would be f of negative 2, because that's what our negative b over 2a equals. And we'd say equals negative 2 squared plus 4 times negative 2 plus 3. So I just took negative 2 and plugged it in for all my x's. So that would give me 4 minus 8 plus 3, which would equal negative 1. So my vertex would then be negative 2, negative 1. Okay? To find the min or max value, it is going to look exactly the same as vertex form. And our A was positive, so that's a minimum. And the y value of the vertex was negative 1. Okay, to find x-intercepts here, we have to do something a little bit special here. We actually have to plug in 0 for y, but then we're going to solve by factoring. And I'll show you what that looks like, okay? So let's plug in 0 for our y. So that's going to be 0 equals x squared plus 4x plus 3. Now remember factoring where we set up our parentheses? We can't solve an equation when we have an x squared and an x. Those can never combine together. So what we need to do is we need to break it into 2 linear equations, 2 easy equations to solve. So I'm going to factor this, and I'll show you how that works. Split up x squared as x times x. And remember, you got to figure out what multiplies to be 3 and adds to be 4. Well, 1 and 3 are your only options here, which makes this problem a lot easier. Okay, so rather than having one big quadratic, we have 2 small linears. Now we want to know what makes this 0, because I know that if I multiply by a 0, that's how I could get my equation equal to 0. So I have 2 possibilities. Either x plus 1 equals 0, or x plus 3 equals 0. So I've got to think what x value will make x plus 1 equal to 0. If you're not sure, you just solve it like an equation. This would give you x equals negative 1. Then I would do the same thing on the other side. What x value would make x plus 3 equal to 0? Well, if I subtract 3, I'll see that if x was negative 3, I would get 0. So my x-intercepts for this problem are negative 1, 0, and negative 3, 0. Okay? And then our y-intercept, when you're in standard form, it's actually very, very easy. You just look at C. And the reason is because if I look at my equation here, if I plug in 0 for my x, just like we did in the previous problem, all right, I would see that this goes away and this goes away because they're just 0, and all that's left is your c value. Make sure you write it as a point, and there's your y-intercept. Okay, the last form we're going to look at is factored form. So, guess what? Opening up or down is exactly the same. You just look at A. Now, where is A located in factored form? Well, our general form of factored form is A, x minus r1, x minus r2. So it is that leading coefficient here in front. It comes before the parentheses. So in this case, A is just an understood 1, which tells us we're opening up. The axis of symmetry here, we actually think about how we can find our x-intercepts from factored form first. So I'm going to scroll down and do that, and we use that to help us find our axis of symmetry and vertex. So if I want to find my x-intercepts in factored form, what's a really cool trick is we actually just have the opposite of each factor. Okay, and I'll show you what I mean by that. So again, it's the idea that we're plugging in 0 for our y, so we would have this equation here. Now, if you notice, this looks like our standard form solving. Well, if we look at our answers, if I want to answer the question, what makes x plus 3 0, it's just the opposite of 3. X has to equal -3. And if I want to know what makes x plus 1 equal to 0, it's just the opposite of +1, which is -1. There are a few cases where you have to be careful, and we will explore those later. But right now you can just remember that, oh, you have that sign switch, and that gives you your two x-intercepts. So let's write them as coordinate points. And there you go. Okay, so now that we know that our x-intercepts are -3 and -1, we know that our axis of symmetry has to be in between those because of our rule of symmetry, right? The x-intercepts should be equidistant on both sides. So we're going to actually average those to find the middle point between -3 and -1 on the x-axis. So I'm going to come back up here to our axis of symmetry, and I'm going to say that you just need to average your x-intercepts. Okay, and we know our x-intercepts were -3. So to average, I just add it all together. We only had 2, -3 and -1, and divide by how many there are, which are 2. Okay, and that would then give us -3 plus -1 is -4 over 2, which would give us -2. Always write your axis of symmetry as an equation, and we're done. And just like before, we use our axis of symmetry to find our vertex. So how do I find my vertex? I plug in my axis of symmetry. Okay, so that would look like f of -2 equals -2 plus 3 times -2 plus 1. So I just plugged in -2, which was my axis of symmetry. Right, x equals -2. I plug that in wherever I saw an x. This gives me 1, -1. Multiply that together, I get -1. So put your vertex together, you have -2 for x, -1 for y. All right, minimum maximum value. Guess what? It's exactly the same. So we know that our A was positive, and that gave us a minimum, and the y value of our vertex is -1. Okay, we've already found our x-intercepts, so the last thing we have to do is find our y-intercepts, and it's actually pretty easy in this form. We are going to go back to the idea of just plugging in 0 for x. That's your basic idea for finding y-intercepts. So I'm going to take my function, plug in 0 for x. So instead of plugging in -2 like we did before, I'll plug in 0. And 0 plus 3 is 3. 0 plus 1 is 1. 3 times 1 is 3. Right as a coordinate point because we're talking about a point on a graph. Okay, and we have now found all of our intercepts. I will also save this document and upload